Hi guys, I thought I'd use this video to explain some of the basic index laws to you. Hopefully these laws, after a while of practice, will become fairly intuitive. But the basic laws we have are, we've got the multiplicative law, the division law, and we have like a bracket law. Now, we'll use examples to basically explain why these things work. So the multiplication law says if we have the same base and we multiply them together, we can add the indices. So the reason this works is, let's say we have, rather than n and m, we have a to the power of 3 times a to the power of 4. Now, what this effectively equals is a to the power of 3, which is just a times a times a, multiplied by a to the power of 4, which is times a to the power of 4 times a times a times a. So what we've got here is we have a to the power of 3 and we have a to the power of 4. Now, as you can see, this is now equal to a to the power of 1, 2, 3, 4, 5, 6, 7. Which is equivalent to a to the power of 3 plus 4. So you can see why the multiplication law works is because if we split each of the indices or each of the bases up into its respective index power, we can just add them. So if we go to the next one, it has basically the same story. If we have a to the power of n divided by a to the power of n, we're going to replace these. Let's just a to the power of 5 divided by a to the power of, 2. Now this is going to be equal to a to the power of 5. Let's just put the division sign first. Is a times a times a times a times a. So you can see that it's going to be along the same sort of logic as the law above. And a to the power of 2 is a times a. Now, what we can do, because these are all multiplications, is we can cancel out some of these. So this will cancel out to make 1, and so will this. So what we're left with is a times a times a over 1, which is equal to a to the power of 3. So you can see that this is equivalent to a to the power of 5 subtract 2. So you can see that that's why the division power works by minusing the index, because the minusing basically takes into account of these bases cancelling each other out. Now, finally, let's do this last one. We've got a to the power of n all to the power of m. So what we're going to do here, we're going to go a to the power of 3 all to the power of 2. So this is equal to a to the power of 3 times a to the power of 3, because if we square it, it means we have to times it by itself once, or times it by itself twice, so there's 2 of them. So this is equal to, the first one is a times a times a, so that's the first a cubed, times by the second one, a times a times a. That's the second a cubed. So these brackets are they don't need to be there. I've just put them there to separate the first a cubed from the second a cubed. And what we do then is, you can see this a times a times a times a times a times a is equal to a to the power of 6. So this is also the equivalent of, because if we wanted another one, if we times this by, put this to the power of 3, we'd have a times another one on the end. So this is the equivalent of a to the 3 times 2. So that's why when we have brackets to the power of something, we have to multiply into the bracket. So I hope this helped. They're not very complicated, but sometimes some kids like to know exactly what they're doing when they apply any of these sort of basic index laws. So again, I hope that helped, and I'll see you again next time.